All right, so we got a couple of review problems. These are out of chapter 1 and 2 in Stewart calculus book. Number 1 is a chapter 2 problem. It's a limit. You plug -2 into the denominator, and -8 plus 8 is 0, so you have to start, you got to get to a single term. So, and you notice that it's fairly mundane in that this step I think is easy. X plus 2 over 2x over x cubed plus 8. Now, I don't know how much pre-calculus you remember about factoring, but if I slide this stuff down a bit, I can flip this up and I can write this as the limit as x approaches -2 of x plus 2 over 2x times x cubed plus 8. And right now you know one fact. If you can't cancel the negative, if you can't make the bottom not 0, you're done. And you see this x plus 2 in the numerator. That means that you have to be able to factor an x plus 2 out of x cubed plus 8 for this to work. And it does. Because you remember cubics from your time in pre-calc. And you say, yep, I know x plus 2 will be a factor of x cubed plus 8. And if you don't remember, you can do x plus 2 over x cubed plus 8, right? You can do polynomial division. I'm not going to do that because like I've done so much math, it's hard for me not to remember. Actually, what I do every time, I never remember if it's positive or negative. I know x squared times x makes x cubed. I know I need a plus 4 because plus 2 plus 4 makes 8. And then I'm going to need a middle term that cancels the 4x, which is -2x. This is 4x, this is -2x. Now I know I'm done. And now I can cancel the x plus 2's, put a 1 on top. And now if I put -2 in the denominator, it works. And I want to make sure I don't make a math mistake, so I write -4, and then I got 4 plus 4 plus 4. I think that's 12. -148. Somebody else get that?
Yep.
Awesome. All right, now here's the thing. I don't want decimals. This is what forces you to do it longhand. You could try check your calculator, but I want fractions, right? I want fractions. All right, rolling on. Problem 2. Would you guys like me to do each one complete?
Yep.
Okay, so we'll start with just the first function, g of x. And everybody, a couple of quick facts. It is rational, right? The type is rational. It has a polynomial top and a polynomial bottom. Its domain is everywhere except where the denominator is 0. I don't know the range. Well, I do. But I'll need the graph to do the range. I probably won't ask for range on the test. Even, odd, or neither. This is neither. Because you guys should be able to picture this, because if I move this to the side so I have some room on my dead spot, 1 over x is odd. You guys agree? 1 over x is odd. But what have we done with this graph? We have shifted it to the right. And remember, odd functions can't be shifted up, down, or left, right. If I move this to the right, because they're around the origin. All right?
Oh, so they are odd, but once they're shifted, they are.
Right, right. So this is not odd anymore. Everybody, that's the sketch of the graph. Of course, I've labeled my axes because Mr. Anderson takes points off for that. And I can look here and now note the range of this is all reals except y can't be 0. All right? And I just handled the sketch even on domain, range, and type. Awesome. Let's do the one I probably would ask for range on, which would be letter B. All right?
Why wouldn't you ask for range?
Yeah, I might. I might not. Trig, right? The trig function. The domain is all reals. We know that this domain range is 1 to -1, and it's just multiplied by 2. So the range in this case is simply -2 to 2 for the range.
Right.
All right, now I'm going to graph it before I decide whether it's odd or even, and I'm going to do it 2 ways. I'm going to do it by graph. That's usually the way students see this. And and you guys know how I do this. I just graph a typical cosine, right? And then I just change my my range so it matches. And then I think to myself, hey, if I extend this, does it mirror across the y? It does. So this is an even function. All right? And that's the way I do it. If you substitute, you can substitute and do this problem the same way. If I slide this down, I gotta stop. I gotta get small. All right. If you substitute h of negative x, you get 2 cosine negative x. And you remember that cosine of negative x is simply cosine x, which is simply h of x, right? Which is the definition of an even function. And if you don't remember why, we always think of the triangle. Guys, if we go negative x degrees, we end up in the 4th quadrant. You guys agree? But if I have this triangle, and I draw the triangle in the 1st quadrant, what do we know? We know that the cosine of both of those triangles is positive, right? 4th and 1st. And we also know that the sine is just the opposite sign. That's how we remember this identity right here. All right? Choose a graph. Yeah, that's not a bad way to do it. What's the last one for type? Polynomial. I would just do poly. Even odd, you look at it, even. All right? Domain is all real. We know that because it's a polynomial, you automatically know that. There's no thought to this. And finally, I say, okay, I want to factor this if I'm going to graph it. And I see x squared minus 1. Everybody, I know that factors again, but I don't need it to because I am only going to graph to the right because I know it's even. And I know it's 0 at positive 1. And I know it's 0 at 0, right? And now I just need to know, is it above the axis here? Or is it below? Well, it's going to be like a parabola. All right? I'm going to guess x to the 4th. I'm going to guess, without knowing, guys, Skylar, I'm going to say it looks something like this, roughly, or a W. Like that.
Yeah.
All right. But here's all I would expect you guys to be able to do. You would look between, if I plug in 1/2, positive, 1/2 squared is 1/4, 1/4 minus 1 is a negative, so this is a negative. If I plug in 100, we see it's positive. So all I'm looking for your graph is this, and we know it goes the other way, and it mirrors. And everybody, I wouldn't ask for range on this because how would we figure out where this is? Yeah, we'd have to solve for y, take it, but we don't know where it is for x. That's a disaster. Calculus will help us with that because later on, look, what's the derivative at this point? 0. We're going to find that later. But for right now, how about we just say this for the range? It's at some magical point. I'll call it b. So I would say the range of this is b to positive infinity. I disagree because I wouldn't ask for the range right now. All right. I would ask everything else, guys, and my expectation yx. If you don't put y and x, Albany, I mark it wrong. Or not wrong, but I take points. You guys are used to that. Keep practicing, and it's